Okay, here we are designing one resonance based full bridge converter for wireless power transmission. Here we are using capacitor inductor capacitor network, that is CLLC converter, and it is used for wireless power transfer. So when we vary the distance, the efficiency will change. That is, if we increase the distance, the efficiency will reduce, and if we reduce the distance, the efficiency will increase. Component converter CLLC, and it is given to 5 volt 2 amps load, that is 2.5 ohms. The output voltage, that is load voltage, is taken as feedback and provided to the PI controller based voltage mode control circuit. Here the PI controller will generate the duty ratio according to the error voltage, and that duty ratio will be provided for pulse generation and given it to the bridge, that is full bridge converter here. Okay, and here this is the coupled inductor. In this part is the coil distance, the coefficient of coupling will be reduced. That is, it will vary from 0 to 1. So when the distance is increased, this reduce coupling coefficient, and when we reduce the distance, this coupling coefficient will increase. Here I have provided initially, and this is the load voltage. Here we are getting nearly 5 volt. And this is the efficiency, load power divided by input power. We are getting the efficiency nearly 91% we are getting. For 0.95 as the coefficient of coupling, we are getting efficiency as 91%. So if we vary the coupling coefficient, it means the distance is varied, and .7, and again run the simulation. The simulation is running now. Okay, again load voltage, it is around 5 volt here. And the efficiency, it is in the range of 83%. Okay, the efficiency is reduced here to 83% when we change the coupling coefficient to 0.7. Now again we will change it to 0.5. Again we will run the simulation. Okay, the load voltage is again 5 volt. 26%. Okay, by varying the coupling coefficient, we can simulate the circuit with varying distance. So the efficiency is reducing by reducing the coupling of coefficient, which means by efficiency is increasing here. So for 0.95 as coupling coefficient, we get 91% efficiency. For 0.7 as coupling coefficient, we are getting 84% as efficiency. So it will linearly decrease. And here we see the results here.